I will wait for 1 or 2 minutes more till I start. Okay, let's start. Good afternoon and welcome to the session about secure your on-premises data with Microsoft Information Protection. My name is Rolf Troendle. I'm working as a freelance cloud consultant in my own company, and I'm helping my customers going into the Microsoft 365 cloud since 2004. So it's almost 6 years or a little bit more than 6 years. I'm also a Microsoft Certified Master and Solutions Master in Exchange Server. Before we start with the content, I quickly want to thank our sponsors to make this event happen. Thank you very much. And so let's keep on with the session. My agenda for you this afternoon. First, I will do a quick introduction about the problem statement we have, then some introduction about Microsoft Information Protection, just a quick overview so we know as much as we need to go further in the presentation, and then overview about sensitivity labels, and then integration into the on-premises world of those sensitivity labels, and a deep dive into Fileserver integration with a demo to show you how this could work. And lastly, but not least, if we have some spare time, I will talk about key options in Microsoft 365, including double key encryption. So today's companies have two factors impacting their organizations. So one is the exponential growth in data. We assume that we will have a growth of 4.5 times over the next 2 years in data. That's huge data growth. And the other one is the massive proliferation of places where users consume, store, and share sensitive data, especially in today's remote and home work locations. Data is used outside the traditional company network. So the big questions are, where is your data? Who is accessing your data? And does your data eventually travel externally, for example, into Dropbox or Dropbox for consumer or whatever you perhaps don't want to have your data stored? And therefore, we need to govern and protect our sensitive data while still having productive users working from home and from remote locations. During the COVID security priority survey, Microsoft has seen that 63% of organizations fear some kind of data leakage during the pandemic times, especially because they are the remote locations people want to start work or will work from. And more than 80% of corporate data is dark meaning it's not classified, it's not protected or governed. So we have no insight, no view about these data. So one answer, one possible solution to this problem could be Microsoft Information Protection. And before we go now into technical details, I just want to show you the 4 general stages or 4 general process stages Microsoft Information Protection has. The first one is know your data. You need to understand your data landscape. You need to know where and how your data is stored, and you need to identify your important data and especially identify which data has to be protected. Once you know which data you want or you need to protect, then you will protect it with, for example, with protection actions like write management, visual markings, or encryption. We will see that later. And then the next stage would be prevent the data loss. So prevent the loss of the protected data or unprotected data inside the process, and also use data loss prevention in Microsoft 365 and detection of perhaps risky user behavior. The fourth stage would be data governance. Govern your data automatically, retain your data, delete it if needed, and store as needed by compliance regulations, for example, for 10 years if it's important company data. And all of these stages are powered by Microsoft Information Protection. But in this session, we will only focus on protect your data, and especially protect your data if you want to store it on your own premises systems. So in a nutshell, Microsoft Information Protection, the protection part of Microsoft or Azure Information Protection, is a cloud-based solution to classify and protect your document and your emails. The protection is based on labels or on sensitivity labels. These labels are used to either manually or automatically classify your content. This also depends on your license and on your requirements. And these labels can be configured in the Security and Compliance Center. We can see it here. Here you see some example labels like personal, public, general, confidential, patents, for my eyes only. And in this example, you probably would use from confidential or highly confidential, you would also use not only labeling, you would also use encryption and rights management protection. This is what you could do with this. You can do a classification, only labeling. You can do visual marking, meaning you can mark your header and your footer, and you can do some protection. We will see this in the next couple of slides. So the labels are configured in the Security and Compliance Centers. You need to create label policies and then to assign these label policies to your users. Once assigned to the users can see or can consume these labels in their Office applications. We see here we can see the Word application with the sensitivity label button, and these labels we have just seen are published to this user, and now the user can use these labels and manually apply these labels to documents if needed, and then also classify and protect it according to the label's configuration. Here's an example of a label with a header. You have some header markings that's integrated into the document. Once you apply the label, and you have a watermark here with Contoso highly confidential. This is just to apply also visual protection, so all users know that this is a very highly confidential document, and this should be threaded carefully. So the label configuration, you can do the label configuration in detail, it is possible to apply encryption or just to apply the markings of the contents like we have just seen with the watermark. So we can choose once you create the label, you can choose if you just want to do encryption and protection for files and emails, or if you just want to marking or both, like I do here in this example. In the next screen, or in the once you apply or you configure the protection settings, then you can also configure encryption settings, meaning you can, for example, configure the expiration of your content. You can expire the content once a label is applied. For example, the HR department wants to send out a CV for a job application to the respective team leader. So, for example, in Switzerland, we have to destroy the CVs if we deny the application from the job application. So the HR department who gets the CV from the applicant can then expire this document, let's say 1 week after stamping or after applying the label to it. So the HR department doesn't need to care if the team leader, after rejecting the application, really has deleted this CV or not, because after 1 week, the team leader can't open it anyway. So you can also content expiration configuration can do here. You can configure if you want to allow offline access, especially for the highest of the highly confidential documents. You probably don't want to have offline access. Offline access means the encryption key or the license is stored on the user's computers. You would probably need this if you go to a remote location or to go to a plane and fly somewhere and you want to work on confidential documents. And then you also need offline access. You can configure it and you can also remove offline access possibilities. The next section here you can configure the individual permissions, this label. We will see in the next screen. And the last section here is double key encryption. This is where this feature is hidden. If we have time, I will talk about double key encryption at the end of the presentation. With the custom permissions or with permissions, we can here either use explicit users like this one here, or we can also use groups from synchronized from Active Directory, or just use Azure AD groups to apply the permissions on this template. This rights management permission can look like this. This example grants view permission to a document. You can see it's only view is checked here and allow macros. This means the user can open it, for example, in Word, this Word document, and then view the content, but only view. The user cannot edit, cannot save it under a different name, and cannot print it. This is especially useful in the last example I made with the CV. So the team leader cannot print the CV and forget it in the printer just to have some kind of data loss there. And external users, if you grant permissions to external users are able to use or to consume this content as well if they are granted permission, and either using their Office 365 work ID, if they use Office 365 already or have some kind of Azure AD account, or then they can apply for RMS for individuals account using their normal email address, as long as it's a company email address and not, for example, a Gmail address. Then they also can consume this information, and you can share your protected content with external persons, with external people, especially, for example, your lawyer, where you want to exchange special confidential document like patent application. So we have seen information protection, it's a process, but we focus on the protect part, and we can protect all our Office documents with rights. And once you apply some rights management, then it's also encrypted. You can also encrypt all other files that are not Office or PDF files. For example, if you use a JPEG, then it will only be encrypted, but not rights protected, because you can't apply rights management with information protection to a JPEG file. Microsoft Information Protection is perfectly integrated for sure into Microsoft and Office 365. For example, OneDrive for Business or SharePoint Online. And for sure in Exchange Online, there it's an additional configuration to the Office message encryption part. It's not the same Office message encryption. It's, if you know this feature, it's based on information protection, but it's not exactly the same configuration. You need to do some additional configuration and have additional licenses if you want to use Microsoft Information Protection with Exchange Online. You could also use a SharePoint site and configure a file library there and apply a label to SharePoint Online file libraries. And once you download the file from the file library, then it will automatically be labeled with the label behind, or you configure in the file library properties. This is nice if you want to store your data in the cloud, but what about on-premises data? There are organizations, and I have some customers who are these organizations who want to use the simplicity of the cloud, meaning sharing with externals and the easy key management, but they want to keep their especially the most sensitive data on premises, and they don't want or can't, depending on the compliance or regulation reasons, store this in the cloud if needed. So they want, for example, protect their crown jewels like patent applications. I have a customer, they want to store their patent applications on their local file server, but they also want to have these rights management protected. We will see this later. Now, if you want to integrate the Azure Rights Management or the Microsoft Information Protection part with your on-premises systems, then you can download a nice piece of software from Microsoft. It's called RMS Connector. If you install the RMS Connector software and configure it on your server, you take 1 or 2 servers, normally 2, because just for high availability, then all the other on-premises system will see this RMS connector like it would be a traditional on-premises AD RMS installation. But you don't need to have the on-premises RMS servers. You don't need to have the know-how how to run and to do the key rollovers of the on-premises RMS servers. And especially you can use it with external users easily. So you just have to use the rights management connector. You don't need to have the on-prem servers, and you can integrate SharePoint server on premises, Exchange server on premises, and the file server running Windows server. That's especially important. It needs to be a Windows server file server. The Windows Server file server you can run in 2 modes. Either you connect it directly using FCI to the RMS connector, or you can use the Azure Information Protection client to automatically protect the file on this server, like we will show you afterwards. With this kind of technology, you are able to protect your on-prem data if it's stored in Exchange, SharePoint, or file server running Windows Server, but still able to share it externally and to have the key management externally. The requirements to use this RMS connector is you have to activate the protection service, the information protection service in your tenant. This means if you have a newer tenant, let's say you created it during the last 2 years, then it's not an issue. Then the information protection service is already configured or activated in your tenant. But for older tenants, this has to be done manually in your tenant. You need, like for every other Microsoft 365 service, if you leverage on-premises Active Directory, you need directory synchronization, like we see here in the building blocks graphics. And you need 1 or 2 Windows file servers, Windows servers for the installation of the RMS connector for fault tolerance. And you need internet access. That's a special one because customers or my customers who use such special data and want to protect this data on premises, normally you tend to use some kind of proxy servers. And this is especially important because you need proxy servers without authentication or internet access without authentication, because you can't use it inside the RMS connector software to use authentication there. So in my demo case of the file server integration, I will show you afterwards, I had a customer who requested to have a special file share protected. This special file share was for a patent or applications for a patent, and they wanted to share the documents with their patent attorney, but they also want to have it secured and also protected always, no matter where this document is stored. They also like, during the discussion we found out, they like the idea of having documents dragged into a file share automatically be protected, so we don't have to force the user to use and click the button patents for the label. So they just want to have it automatically protected stored on the file share. Research and development R&D also requested a file share with special protection, with another template, with another label, just to have it for their own usage. And the other requirement was the protection must stay on the documents. So let's say you copy the documents afterwards from the file share and copy to a USB drive, and you lose your drive, let's say on the train station, no one can read these files because they are protected, and the protection, the label applied to the file, travels with the document, no matter where it's stored. Also, if someone, let's say I copy the whole share to my USB drive, take it home, and then I leave the company, I will lose access as soon as my account will be disabled by the IT department. So I won't have any access anymore, and I cannot sell this data if I would like to. And the solution for this requirements was to integrate this file server with information protection. We made the decision to use file server integration with information protection client and not with the shown RMS connector software. The reason behind this was they don't have plans to use their on-prem SharePoint. They don't use on-prem SharePoint currently, but they also have no plans to integrate their on-premises Exchange server with RMS or information protection. So it's no need to implement RMS connector at this point in time. So we decided to use the information protection client, and here I need to note that information protection client exists in 2 versions currently. We have the classic client, and the classic information protection client will be end of life on the end of March next. And then the information protection unified labeling client, they have the same icon in the setup exe file, but they are named a little bit different with the _UL if you go to the download center. So don't use the information protection client, the old one, because it will be end of life, but use the newer one. But the newer one has other PowerShell commandlets. I will talk about this afterwards. Then to implement this into the file server, the steps are first we activated the unified labeling in the tenant. By default, Azure Information Protection is in the Azure portal, and if you want to use unified labeling, you have to activate it manually one time, and then the labels will be synchronized between the old and the new experience. We need to use unified labeling and not Azure Information Protection labels because we use the unified labeling client, and this only connects to the unified labeling service inside Microsoft 365. The next step was to create a fallback user and assign this fallback user an Azure Information Protection P1 license. This fallback user is needed if the script cannot determine the owner user of the file who puts the file into the file share. Then these fallback users will be the owner of the information protected file. Because in information protection, someone has to be the owner. Normally, the user who applies the label is, if you do it manually, you are the owner of the file and you always have full access to the file, and you also could remove the label from the file if you manually labeled the file. So we need to have someone who is the owner, and this would be this fallback account. Is to create a unified labeling like shown some slides ago. We synced some permission groups from Active Directory to Azure Active Directory just to grant the permissions. Normally we used co-author permissions or view only, it depends on the role. And then we granted this right to the users and user groups and published these labels to the users and to the AIP fallback user. The next step to create this integration is to create the enterprise app. If you run the script or you do the classification, the labeling on the file server won't use a service account like a classic service account. It will connect to Microsoft Information Protection using an enterprise application. You need to add some permissions to this enterprise application. Like there are not many permissions needed. Only information rights management services create protected content on behalf and read on behalf and read all unified policies on the tenant. That's everything additionally needed to the default Microsoft Graph sign-in permission. Once created this enterprise application, you need to note the application ID, and you need to write down the directory or the tenant ID from your tenant, because we will need to configure it later in the scripts on the file server. And then you have to generate and store a client secret. And this secret is like the password for this enterprise application, which we will need later to connect to information protection. Next step is to install the Information Protection Unified Labeling client on the file server and to install the file server resource manager role if this is not already installed. Normally it is because it's a Microsoft file server. Then we encrypt a test file. We will do this using Classify and Protect. Once you install the Azure Information Protection Unified Labeling client, then you will have some new piece here in the context menu. We use this Word document, click on Classify and Protect, and then we will see all our labels up which are assigned to this information protection user. We will use, for the first time, we will use the AIP service user credentials when prompted, and then we will also see and check if all labels are published correctly, because once we see it here, we will know everything is fine in the backend service in Microsoft 365. Then we apply this label. We will do this one time manually just to get out the file information with get AIP file status. we need this file information to get out the label ID to use later on in the PowerShell script. We need to install the information protection client on this file server because this information protection client also installs the PowerShell modules and therefore the PowerShell commands, which we will need inside the classification script. In one of the last steps, we wrote down all the information needed, and now we are ready to implement this scripted or this protect script on the file server. Microsoft provides a very nice template you can find it on this URL here. But with this template, you have to rewrite all PowerShell commands from the old RMS client to the new information protection unified labeling client. They didn't update it so far. So if you want to do it yourself, you just can download the script I used here on this tiny URL link. This will guide you to my OneDrive Anonymous link where you can find this PowerShell script already updated with the right commands. You only have to edit the script then and put in here the application ID, the application secret from the enterprise application, and the tenant ID. You also have to edit the UPN, the customization of the UPN, because the script will search for the owner of the file. If you store a file on a Windows file server, then your logged in user is normally the owner of the file. Once this classification script will go through the file share, it will find this file and use the owner information to get out of Active Directory the email address and the user principal name to stamp the owner for Azure Information Protection onto the file. That's why you have to use your UPN suffixes and to configure it inside the script. The next steps are in Fileserver Resource Manager. You first create some classification property in there just to have it RMS called. This is only a yes/no property. Based on this property, you can then create a classification rule. This classification rule is scoped to the share folder where you want to have this patent label be applied to. And it's a folder classifier. And based on this classification rule, you create the file management task. The file management task is the piece who puts all these things together. It puts together the classification rule, it puts together the PowerShell script, and the file management task is the task in Fileserver Resource Manager who monitors the file share. As soon as you put in a new file in the file share, this file management task will automatically run by Fileserver Resource Manager, which is integrated in the Windows Server. And this will run this PowerShell script and apply the template to the file that was just newly created in this share. In this file management task, you enter the PowerShell executable, and as you can see here, you enter the PS1 file. The source file path is an attribute, a variable which you can choose inside Fileserver Resource Manager, and here you enter the template ID, which refers to your chosen unified label. So if you use several shares with different labels, you can just use the same PowerShell script, but you hand over another PowerShell, another unified labeling template to the script. That's everything that's then together. And now let's have a look how this looks like inside a Windows file server. I hope it's visible. Okay, I stored the information protection, the PowerShell file in CAIP on this Windows file server, and it also creates some debug output just for me if I want to trouble a little bit. On my client, I have in CTemp, I've got a document in here. It's doc demo. I will open it and you will see it's not protected. You cannot see any protection inside here. It's unprotected. I will edit it with the time, just as we have seen. And now I will copy this demo document to my file share, put it in here. It's 14 kilobytes in size. Please note the size, because once the label is applied, the size will increase to approximately 40 kilobytes here in this test document. On the file server, I will wait. The file server resource manager will run soon. It will detect the newly created file. Now it's done. In the debug output, I can see on the timestamp, it found the doc demo docx and it applied the label to it. If I go now back to the client and hit on refresh, the file size just grew to 41 kilobytes. So I can assume it's already protected. And if I double click the file, Word is opening the file. And voila, it's protected with the label patents. I can see it here. Encrypted patents is this description name. And if I click on view permission, I have owner permission with this account here, and it's fully encrypted and protected, and therefore I could store it on my USB drive and lose it on the train station if I would like to. That's everything needed to implement it on a file server, and my customer is happy to put in here now his new documents, not only Word documents, all of his office work. He also puts in some CAD drawings from AutoCAD, which will then be also encrypted, not with DRM protection. There would be available there are third-party plugins available for different CAD applications if you are looking for this, but it's not out of the box from Microsoft available. So back in the last minutes, I would like to talk about key options, because this is always a discussion once we implement RMS and once we implement information protection. Then the customer asks, yes, and who stores my key? Who has the root keys for all this stuff? And how is the encryption working? So to protect your data inside Microsoft 365, in general, you have three key options. You have the customer key, but this is a tenant option. You have bring your own key for information protection, and you have hold your own key or double key encryption for information protection. The first option, customer key. This option is only used to encrypt your data at rest, meaning to encrypt your data that's stored inside the service with your own key. It's a bring your own key option for your whole tenant, meaning if you use this bring your own key or customer key option, all your tenant data like mailboxes, like OneDrives or SharePoint sites are encrypted on the storage in your Microsoft data center using your own key. When you create this key, then it is stored in a hardware security module, which Microsoft uses also third-party hardware security modules inside Microsoft 365. They only can use the key for encryption for your data, and they can use the key to replicate between data centers just for high availability. At this point in time, all of your data at rest is encrypted using this key. And if you revoke this key, then it will also destroy the availability key. So let's have a look at this for an Exchange mailbox. Primarily, you see the RSA keys. You have two customer keys. You always have two. You have to bring two keys, your customer's key and the root keys store. This is an Azure Key Vault inside Azure where you will put it in place. It will also create an availability key. This is the key used if you lose your customer keys. I don't know why you accidentally destroy it or you accidentally destroy your Azure Key Vault. Then you can request from Microsoft the availability key. Microsoft can't use this is as far as I know, it's a certification-based process. They only can hand you out or activate the availability key once you request it, and they can't use it themselves without your permission. Then these keys are used to encrypt the data encryption policy key, and the data encryption policy key is then used to encrypt to protect the mailbox key, which is used to protect your individual mailboxes. The same is true for SharePoint Online and OneDrive for Business. You also have at the top level your two customer keys and then the availability key, and in the middle are the tenant intermediate key and the site encryption key. And then especially in SharePoint Online and OneDrive, all files are split into file chunks, and each chunk has its own encryption key, and this encryption key is protected by all those keys up above. So this is only used to encrypt it for compliance reason. You have your own encryption keys inside Microsoft 365. Once you download your OneDrive data to your drive, then it's not protected anymore. So for information protection, you have also different key options. The default one is Microsoft Managed Key. If you don't do anything, you just activate information protection, then you have Microsoft Managed Key. It's software as a service. You have to do anything and it's protected. And I would say it's secure by default. But if you have compliance requirements, you can also bring your own key here. You upload it also into an Azure Key Vault. And you use this option, for example, if you have compliance requirements like key lifecycle or rollover policies, or you have compliance requirements that you have to generate all your encryption keys in your company hardware security module, and you must be under control about how your keys are being generated. The other options for information protection are hold your own key. This is legacy with the legacy information protection client, and the newer version is double key encryption. And with double key encryption, this is the only option where you will store your encryption key for your sensitive data outside of Microsoft's reach. I would like to show you how this works. This works like this. First, you are an end user and let's assume you are altering a document that needs to be protected by double key encryption. First, your Office client and everything for this runs inside the Office client, bootstraps the information protection service public key from the information protection service. Then next, the Office client bootstraps the double key encryption service public key from the double key encryption service, and then the user authors the document and encrypts the document using a symmetric key. And this symmetric key is generated on a per client, per document basis. It's generated inside your client. That symmetric key is placed in the document metadata and is first encrypted using double key encryption service key. And then it is wrapped again using the Azure Information Protection Service key, symmetric, and then the symmetric key is protected by both keys. And you cannot unprotect this document without having access to the double key encryption service outside the Microsoft service. The decryption workflow is primarily the same process, but in reverse. We will see it here. The Office client sends first the metadata portion of the file up to the information protection service. And if the user is authorized in the Azure Information Protection Service, it will decrypt the outer Microsoft key and return back to the client only the metadata that is still protected using the double key encryption. The Office client then will request access to the double key encryption service. And if the user is authenticated, then it will return back the symmetric key to the user's machine. And the user's machine will then go ahead and decrypt the document and render it to the user. And at no point in time, Microsoft has the ability to see the data, and the data is never sent outside the client. So much for double key encryption. For your reference, here are the key options summary, the key options which you have inside Microsoft 365. Bring your own key, as mentioned, for regulatory compliance, customer key for your data at rest, and hold your own key and double key encryption for information protection, which then runs on your Office client inside the information protection service. So that's it from my side. If you have any questions, I'm here. I would like to answer those questions, hopefully. And if you had some fun, please fill out this survey, this feedback form here. And then, if not, I wish all of you a nice afternoon. And thank you very much for being here.